Beams are the backbone of modern construction, supporting everything from bridges to skyscrapers. But not all beams are created equal. Today, we'll explore 5 of the most common beam cross-sections: I-beam, T-beam, L-beam, rectangular, and circular. We'll dive into what makes each one unique, how they handle forces, and where they are used in construction. 1. I-beam cross-section. Let's start with one of the most widely used beams in construction, the I-beam. As its name suggests, the cross-section looks like a capital I. This design gives it excellent strength-to-weight ratio, making it perfect for applications where both tensile and compressive forces are at play. The I-beam has 2 horizontal flanges that resist bending forces and a vertical web that handles shear forces. These beams are commonly used in building frameworks, bridges, and industrial structures because of their ability to support heavy loads over long spans. Engineers use I-beams when they need a strong, lightweight, and efficient beam to span long distances, like in bridges or large buildings. 2. T-beam cross-section. Next, we have the T-beam. As the name implies, the cross-section looks like a T. This beam is essentially an I-beam with only one flange. It's often used in floors and bridges where the slab above the beam can act as the top flange, giving it added support. The single flange on the top resists bending, while the web below handles shear, just like in the I-beam. However, without a second flange, T-beams are better suited for applications where the structure above can help carry some of the load. You'll often find T-beams in bridges and floors, where they're integrated with concrete slabs to form a composite structure. 3. LBeam CrossSection. Now, let's move on to the L-beam. This beam has an L-shaped cross-section and is used in areas where load needs to be transferred in 2 perpendicular directions, such as corners of buildings or frames. The L shape helps distribute forces along 2 planes, making it useful in structures where the load is not evenly distributed. One leg resists bending in one direction, while the other leg provides support in the perpendicular direction. You'll often see L-beams in floor framing systems, walls, and corners where additional strength is needed at the intersection of 2 planes. 4. Rectangular beam cross-section. The rectangular beam is a simple and versatile design. Unlike the I-beam or T-beam, it doesn't have specialized flanges or webs. Instead, the entire beam acts to resist both bending and shear forces. Because of its straightforward shape, rectangular beams are commonly used in residential and commercial buildings, especially in areas where aesthetic or architectural considerations come into play. However, rectangular beams aren't as efficient as I-beams or T-beams when it comes to supporting large spans, which is why they're typically used in smaller structures. 5. Circular beam cross-section. Finally, we have the circular beam, often referred to as a hollow cylindrical section or pipe. This cross-section is ideal for structures where the load is distributed evenly along the entire surface, such as columns or structural supports. The circular shape resists torsion, twisting forces, better than other shapes, making it useful in applications like bridges, towers, and offshore platforms where the structure may be subject to wind or water forces. Because of its ability to handle both compressive and torsional forces, the circular beam is often found in structures that face varying loads from different directions. Conclusion. So, there you have it, 5 of the most common beam cross-sections in structural engineering. From the highly efficient I-beam to the versatile rectangular beam, each cross-section plays a crucial role in the world of construction. Choosing the right beam can make or break a structure, quite literally. By understanding how each of these beams handles forces, engineers can ensure that their designs stand the test of time. If you enjoyed this breakdown of beam cross-sections, don't forget to like and subscribe for more content on structural engineering and construction design.